The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're looking at controversial topics at the intersection of healthcare and ethics. Hello and welcome to Science for the People. I'm Desiree Schell. A little later, science writer David Dobbs joins us to explain the showdown between the FDA and personal genomics company 23andMe. But first, I'm joined by Timothy Caulfield, a Canada Research Chair in Health Law and Policy and a professor in the Faculty of Law and the School of Public Health at the University of Alberta. He's also the author of The Cure for Everything, Untangling the Twisted Messages About Health, Fitness, and Happiness. Welcome back, Tim.
Hello.
You are here today to talk about stem cell tourism, but maybe let's start out with a bit of background for the folks. What are stem cells?
That's actually a great question because there is sort of a ongoing conversation in the scientific community exactly what stem cells are. You know, for the purpose of the general public, I think that we can give a sort of broad definition about what stem cells are. And I think what people most associate with stem cells are the ability of a cell to become any other cell in the human body. And that is why there's been so much excitement around stem cells and stem cell research, because there's the hope that by coaxing a cell into becoming, say, a liver cell, a heart cell, perhaps a neuron, we are going to be able to treat and perhaps cure a whole range of human diseases. In addition to that, because of this ability of stem cells to become other cells, it's often been called pluripotent if they can become any cell in the body, or multipotent if they can become a few cells in the body. Because of that ability, stem cells also provide a remarkable opportunity for research. Perhaps you can use, for example, stem cells to do drug research, or you could use stem cells to experiment on different kinds of tissue. So there are huge possibilities with stem cells, and that is why there's been so much excitement. In fact, I think you can make a strong argument that they have been the most publicized form of research over the past decade, and as I said, for good reason.
They have definitely been well publicized, and part of that is from a very controversial aspect. So what is the concern around stem cells?
I think you could make a strong argument that no other field of science has been as controversial as stem cells in the past 50 years. You know, you're talking nuclear science, perhaps GMOs, but really it has been a huge focal point of social controversy, and that is largely because the primary source of the most useful forms of stem cell, at least early days, was from human embryos. And it required the destruction of a human embryo really to get the stem cells needed for the research. And as a result of that, they became a focal point of ethical controversy, of legislative action, really around the world, not just in Canada, not just in the United States, not just in the UK, but really around the world. And we saw a diversity of approaches emerging around the world on how to handle that very issue, with some jurisdictions banning stem cell research, other jurisdictions allowing very particular kind of research. So you had that controversy, and it really largely flowed from the fact that we were using human embryos for research purposes. But I also think it became kind of a proxy, you know, stem cell research in general, kind of a proxy for the angst society has around the speed of scientific advance more generally. You know, this idea of human cloning emerged at the exact same time as a lot of stem cell advances were happening, and in fact, they kind of merged when you around the idea of therapeutic cloning, using cloning technology to create stem cells. So you had, I think, you know, in addition to the embryo controversy, you also had sort of stem cells emerging as a kind of a proxy for this general angst around the rapid advance of science generally. So I think those two things caused stem cells to become a focal point of social controversy, which has had a huge impact not just on how we talk about stem cells, but on how the research has progressed.
Well, is it just my impression, or has it actually become less controversial over the years? Because I don't see it as
You're
often
right,
in the news
and
now.
we've been mapping this really closely. We've been following sort of the media coverage of stem cells. It remains, in fact, I'm surprised actually the degree to which it has remained in the headlines. But for sure, the social controversy has decreased. And I think there's a number of reasons for that. First of all, I think that, despite all the controversy, most people in most countries strongly support stem cell research, even in the U.S., right, where, there was a big pushback by a certain sector of the population. Most people support stem cell research and excited about the possibilities associated with it. Yes, one can argue that support perhaps is artificial and it has been based on hype associated with the science, but I think it's fair to say that most people support science generally and also support stem cell research. So I think that's one reason that the controversies has gone down. And there's also been sort of this social accommodation associated with the science. But in addition to that, there have been new forms of stem cell research that have emerged that don't require the use of embryos. iPS-induced pluripotent stem cells is the best example of this. In fact, the inventors of this form of research received the Nobel Prize last year. And this is the idea of taking a normal cell, say a skin cell, and genetically altering it to trick it into thinking it's a stem cell, or even trick it into thinking it can behave like an embryonic stem cell. And because of that, there isn't as much interest in embryonic stem cell research. So that's another reason I think it's decreased. And finally, I think that the other areas of stem cell research have caused even more controversy, and perhaps we can talk about this later. Things like stem cell tourism, things like getting consent to use cells, things like how these transplants are going to happen and the regulatory process around these kinds of transplants. All these other kinds of social controversies have kind of taken over. And in fact, we've done some survey research and found this is in fact the case, that concern around cloning and embryos has decreased, and the social concerns around how this technology is going to be translated into clinical use have increased.
So things that are scarier made stem cells less scary.
Kind of. That's right. I mean, what's really happening is, look, people aren't as concerned about cloned armies, and they're not as concerned about embryonic stem cell research as they were in the past. But we are seeing sort of the implementation concerns emerge. Okay, now we have this technology, now we have this science. How's it going to play out?
Well, you mentioned stem cell tourism, so we might as well start talking about that now. Can you define that term?
To be honest with you, it really is not a great term, because what it refers to is people traveling to other jurisdictions around the world to get stem cell treatments that are largely unproven. And the reason that the term stem cell tourism is not great is tourism kind of denotes a frivolity to it, right? This idea that people are traveling to have fun. And on the contrary, these are often people that are very, very sick, and sometimes they're desperate, and they're looking for treatment or cure for very serious disease. And often they're paying tens of thousands of dollars for these treatments. So it's a serious problem. It's very difficult to get a sense of how big of an issue this is, but it looks like it's a huge issue, right? That thousands of people are traveling all over the world for these treatments. And it is to receive treatments that are largely unproven, right? These are either completely unproven or very speculative forms of treatment. And the concern is that people are either being completely fooled, that there's an element of fraud involved, or that these technologies are being used at least prematurely.
Is this a recent development then? Why are we hearing so much about it now?
It's a recent development in the context of stem cells. But look, every single time throughout human history almost that there has been a scientific advance, be it in the context of electricity. When magnetism was first kind of discovered, the whole phenomenon of magnetism, there was therapies based on magnetism, or you could get magnetic belts that you would wear to cure a whole range of diseases. When radioactivity was discovered, then there were all these treatments based on radioactivity. In fact, you could order radium water. It was actually radioactive water in order to cure a range of diseases, and on and on. Anytime there is a highly publicized scientific advance, there's often bogus treatments associated with it. So it's not new in that sense, but the fact that stem cells have received so much press and is so much in the public imagination, it served as a wonderful opportunity to market and sell largely unproven, or I think almost completely unproven therapies to people who are in desperate need of treatment.
You're listening to Science for the People, and I'm here with Tim Caulfield, a Canada Research Chair in Health Law and Policy, talking about stem cell tourism. Now, many of the clinics that offer stem cell therapies advertise directly to the public, correct?
Well, it is almost entirely an internet-based industry. Yes, there's things like word of mouth, and there's a lot of social media involved, but it almost is entirely based on web-based advertising. So if you have an ailment and you want to find a cure for it, and you go to the computer and you Google stem cell therapy for any disease, you will immediately get a whole list of clinics from all over the world. And these clinics look tremendously sophisticated. So if you click on the website, you'll see a clinic that looks very modern. You'll see it looks very sophisticated from a scientific perspective, and they will offer treatments for a range of ailments, from MS to heart disease to various cancers to a whole range of other neurological disorders. They really will have a stem cell treatment for just about anything, you name it. And so because it's an internet-based industry, that raises a number of problems from the perspective of studying the phenomenon, because there is no clear record of who's going to these clinics. It's very difficult to get a sense of the numbers of the individuals going to these clinics. It's very difficult to get a sense of what these individuals are actually told when they go to these clinics. In addition to that, it makes it very difficult to regulate this area, right? It's very difficult to regulate an international industry that is largely internet-based. How do you get to it? How do you stop it? How do you improve the situation? And so this is, as I said, seems to be a growing phenomenon and largely internet-based.
Well, you were part of a group that studied or attempted to study the
Mm-hmm.
websites of these clinics that advertise directly to the public. Can you take us through that research?
Yeah, we were fascinated by this phenomenon. Now, our team has been doing research in the area of stem cells really almost from the start, from the late 90s. We've been very fortunate to have a great interdisciplinary team where we've been studying the legal and ethical and policy issues associated with this exciting area. And as we were doing that, we really noticed, this growing phenomenon of stem cell tourism, and we thought, this looks like it's going to be the next big issue. And in fact, some of our research has found just that most of the researchers in the area of stem cell research view this, the provision of unproven stem cell therapies, as the biggest issue. And what we decided to do was look at what is being advertised in a very systematic way, what's being advertised on these websites. We brought together, as I said, an interdisciplinary team that involved people who are experts in technology assessment, people who are experts on, we had a linguist involved, people who are experts at sort of doing content analysis. And we tried to very objectively get a sense of, okay, what's being offered, what kind of remedies are being offered, what's the tone of the website, and is there any evidence to support any of these treatments. So our first study we did in 2008, and the results were striking. What we found was that these clinics, first of all, they're all over the world, are offering treatments. And when we did it, we found the average price to be about $30,000 per treatment. And other teams have since found it to be more than that, around $50,000 per treatment. So if you include traveling to the jurisdiction, staying for a while, multiple treatments, you quickly get into hundreds of thousands of dollars. The other thing that we found was that these clinics largely present these treatments as routine and effective, and that the risks were minimal. So, this was problematic. In addition to that, for this 2008 study, we also tried to get a sense of what the literature actually said about the efficacy of the offered treatments. And again, no surprise, we found almost no support for the provision of any of the therapies. So the results were quite striking and quite definitive. These were unproven treatments that were being presented to the public in a very sophisticated way as being efficacious, routine, and largely risk-free.
So now these websites, they mainly advertise therapies to treat neurologic and cardiovascular diseases?
Those are two of the big areas for sure. But you know what? They offer treatments for everything that you can imagine. A clinic, there's variation between the clinics. Some offer just sort of generic anti-aging treatments. Some offer treatments for every single disease you can think of. In fact, they're often presented alphabetically because there's so many that they allegedly have a stem cell treatment for. Others offer treatments that are sort of more frivolous, that are cosmetic in nature. In fact, that's a really growing side of the story. the offering of stem cell treatments for cosmetic purposes. Others focus more on athletic injuries, joints and things like that. But the bottom line is there are stem cell treatments, unproven stem cell treatments out there that you can get for almost anything that you can imagine. Now, what we have done is, in fact, we published a study, and you may know this, very recently, where we redid the last study, right? Because we wanted to know if things were getting better. And our hypothesis actually was that there has been so much discussion about the problems associated with stem cell tourism that things would have improved. And we thought that perhaps these clinics were reframing how they were presenting these treatments. Perhaps they were now saying, look, these are experimental treatments, which would still be problematic, but we thought maybe the language would be moderated. And to our surprise, it's not the case at all. If anything, the language is just as definitive and perhaps even more so.
Well, and we probably should point out that it's difficult to tell just via the website whether they are even providing stem cell therapies, whether or not they claim to be doing that.
Who knows once the person goes to these clinics what's being offered? What do they get when they get there? And the other very common thing, and this is true with all forms of quackery, I want to be careful because who knows what's going on in these clinics, as you point out. But the very common theme is that they back up their claims through patient testimonials of success, et cetera, not through clinical data, not through peer-reviewed clinical data, which is what you really need in this kind of situation, obviously.
How exactly did you go about figuring out whether the therapies that they were offering, whether they were actually supported by peer-reviewed clinical evidence?
Well, this was the nice thing about having an interdisciplinary team. I'm fortunate to be part of a team that's funded by the Stem Cell Network, and so we could draw on scientists who are actually doing stem cell research. I'm also have colleagues here at the University of Alberta who are experts in HTA and health technology assessment, so they know how to assess the existing literature in a way that would suggest whether a given technology is ready for implementation, right, for clinical use. So we did it tried to do it in a very systematic way. Now the later study, the one that we just published, we just looked at the language on the websites. We didn't revisit the efficacy of every technology because it was a slightly different goal in that study.
Right.
But I think that given how institutions like the ISSCR, the International Society for Stem Cell Research, how those kind of entities have responded to stem cell tourism, I think it's fair to say that efficacy remains a big issue.
Now, is any of the stem cell treatment direct-to-consumer advertising illegal?
That's a very good question. In a lot of these jurisdictions, they have regulatory frameworks that are supposed to catch the provision of unproven treatments, and they're falling through the cracks, obviously. China is a very good example. India is another jurisdiction where many of these clinics are being set up. In Mexico, there are clinics in the U.S., but those clinics have largely been shut down because the FDA in the U.S. has decided, and I think rightly, that they have jurisdiction over this area. So there are currently no clinics in the United States, at least that I'm aware of, that are offering these services in the U.S. And it would be the same in Canada. So are they illegal? They're illegal in the sense that if you are in a jurisdiction that has an entity like the FDA or like Health Canada that requires approval before you can provide it, then yes, it would be illegal to do that. But there is a lot of discussion about how these, entities like the FDA and like Health Canada, how they should actually monitor this area. So there's ongoing debate about that.
Speaking of the FDA and Health Canada, that's one of the things that I hear, that there's concern about the delay in approving clinical studies on therapies that look like they might have potential, and that's one of the reasons that we do see the stem cell tourism.
I hear that over and over again, actually, when I have the opportunity to speak to the general public on this topic. And you hear that, and often you hear that quite strongly coming from the general public, that, look, regulators are delaying the implementation of these technologies that can be useful. Look, I absolutely agree that we want to make sure the regulatory process is as efficient as possible and that efficacious treatments get to the clinic as quickly as possible. But the science simply isn't there yet. It really isn't. And for most areas, we are a long, long way from the clinic. It's not like we have clear signals from the clinic as a result of, well-run clinical trials that there are some therapy that's, very close to being useful, and therefore we need to get it into the clinic. So look, I hope it happens quickly, and I hope there's a breakthrough quickly, but right now, for almost any disease that you can name, we are a long way away from having a clearly effective stem cell treatment. I remain very optimistic. I genuinely think this is an exciting area of research, and I do think we're going to have therapies in the future, but they're not ready yet. In addition to that, people have to remember what the goals of these regulatory bodies are. It is public interest. It is supposed to be the public interest. So they want to make sure that these treatments are effective and that their risks are minimal. And if you're putting pluripotent stem cells into a human individual, the risks are real. Whether it's tumors, whether it's infection, whether it's the cells not behaving the way they're supposed to behave, there could be real problems. And unlike a drug, once these cells are in you, it's hard to get them out, right? So there are real risks. So I think we do need regulatory oversight, but I would like to see the best of both worlds, where we have good regulatory oversight, but the regulatory process is as efficient as it can be.
This is Science for the People, and we'll be back with more of Tim Caulfield and stem cell tourism after this.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
Welcome to Science for the People. I'm Desiree Schell, back with Tim Caulfield, a Canada Research Chair in Health Law and Policy, and author of The Cure for Everything, Untangling the Twisted Messages About Health, Fitness, and Happiness. We have been talking about stem cell tourism. Now, you mentioned earlier in the show that there definitely are other kinds of medical tourism, and there always have been. But do you think stem cell tourism is worse somehow?
In some ways, I think it's worse, and bear with me with this answer. You're right. There has been medical tourism for a very, very long time. We've seen it around cancer, where there's been crazy treatments for cancer, around other kind of alternative treatments. And it is also a phenomenon that has a long history. So I think that stem cell tourism now, is it worse? I think it's part of a bundle of new forms of stem cell therapy that are worse in that they are sort of exploiting the excitement around real science more so than they ever have in the past. So I call this science exploitation. What happens is you have an exciting area of science, be it genetics, stem cells, nanotechnology. You can think of these kind of cluster of new exciting areas that have gotten a lot of press. And providers of these bogus treatments take that excitement and exploit it in order to sell bogus treatments. And why it's so problematic is it's becoming very, very difficult to tease out the real stuff from the bogus stuff. And in fact, look, I've been studying this since '98. And often I have difficulty getting a sense of, okay, where is the science really at with this particular treatment? Because the clinics are getting so sophisticated at marketing what looks like a proven and effective treatment. And that's because of this science exploitation phenomenon that they can take the genuine excitement around a legitimate field and exploit it to sell. And it becomes really difficult to tell the good stuff from the bad stuff. So is it worse than in the past? It's not worse in the sense that this has always been happening and people have always been exploited, but it's worse in the sense that it's becoming increasingly difficult to tease out, to make that determination of what's real and what's not real.
Well, then who are we blaming exactly?
Well, that is an excellent question and a controversial one, actually, because I think some of the blame, and I don't know if blame's the right term, but let's go with that for now, part of it's the scientific community. Part of it's even people like me, that have been so excited about this field. And, there has been so much hype. You look at a Time magazine cover that says that stem cells can treat diabetes or stem cell treatments are just around the corner or that, they're talking about, sports stars getting stem cell treatments. And that language of hope has been around for a long time. So if you have a sick child and you see that kind of language coming out of real scientists, right, you can understand why the market exists. So you have that element. I think that's part of the story. Adding to that, is what you talked about earlier, is the controversy. Because this was such a controversial area of science and remains a controversial area of science, there's been a polarization in the discourse. So you really do have sort of this extreme language around stem cells. It's going to save lives. We can't stop it because it's going to cure all these diseases. And again, that has added to the opportunity for clinics to exploit, right? Because you have this sort of extreme language. In addition to that, I think that scientists all over the world are under increasing pressure to translate science quickly. Governments want a return on their investment. You're seeing that happening in California right now, seeing it happening in the UK. We've given you millions, billions of dollars to do this research. Let's see some clinical output. And again, that results in language that makes it sound like science is closer to the clinic than perhaps it really is. So I think I won't actually call it blame. I just think there's a lot of systemic phenomenon that's occurring that creates an atmosphere where stem cell tourism can thrive.
Well, do you think that polarization in some of the language has, I guess, contributed to a bit of a conspiracy theory mindset? Is this one of those ideas that they don't want you to know and you cannot see my scare quotes, whoever they are?
Yeah. I think, again, another great point. And I hear it from, people in the audience when I'm talking about this issue. I do think there's a conspiracy theory. So first of all, there you have the classic big pharma one that seems to never go away. The idea that somehow big pharma is controlling researchers and that they don't want us to cure these diseases because they want us, again, scare quotes, they want us to continue selling drugs. There's that kind of conspiracy theory. But there's the more, I won't call it legitimate, but there's the one that has sort of more social traction, and that's the idea that somehow we want stem cell research to happen in our country, and if you go overseas, we're somehow undermining stem cell research here, and therefore we're going to put down the therapies that other jurisdictions are providing.
Oh, interesting. I haven't heard that one.
Oh, I've heard it. Heard it for sure. And so, you have that kind of conspiracy theory going on also, right? That somehow there's some kind of Western ownership over the science. And then there's also the broader kind of what is knowledge conspiracy theory, the idea that we're trying to impose a very specific kind of view of science on these that doesn't necessarily apply. I really don't. I don't buy any of these conspiracy theories, but we're just not that organized as a society. But I really don't buy that last one because you often hear that in the context of complementary and alternative medicine, the idea that you shouldn't use the normal standards of science to measure efficacy because it doesn't apply. Well, the people who are providing these unproven treatments clearly are trying to position themselves within the scientific community, right? They're trying to say, we are stem cell scientists providing cutting-edge science, so they should be held to the standards of science. And so there are all these conspiracy theories around. I don't buy any of them, and I have never seen any evidence that they exist. Every scientist I know that is working in this area is trying as hard as they can. Their whole lives have been dedicated to getting this research to the clinic as fast as they can so they can help real patients.
Well, now, something that we touched on earlier, the idea of it's understandable that consumers might be very willing, for whatever reason, to put faith in an unproven treatment. But there is still a difference between an experimental therapy and a therapy which is absolute pseudoscience, is there not?
Yes, and I think this what you speak of here is going to become a larger problem in the future. You have experimental treatment, and that happens all over the world, right? Where there is some basic science to support it, perhaps there's some animal research to support it, and the idea is they're in a desperate situation, so let's provide some experimental treatment. There's a couple things we have to remember with that. That isn't a study, right? Because it's not controlled in the proper manner. It doesn't have the methods that are necessarily appropriate in order to get really robust data. But that does happen sort of in the clinical setting. But even here, we have to remember that for most of the stem cell treatments that these clinics are providing, the data isn't even strong enough to suggest that, right? To suggest that we're ready for that kind of use of these technologies. In addition to that, only rarely are these clinics even suggesting that this is experimental. As I said, our most recent study showed that these clinics are still presenting these treatments as efficacious, relatively routine, and relatively risk-free, which would not be the case at all, of course, if this was truly sort of experimental treatment. So why do I think this is going to be a bigger problem? So let's say we move forward in 10 years from now, or even 5 years from now, if we're lucky, and some treatments are in the clinic and they are looking like they're signaling towards efficacy. Say a new MS treatment, and it's a robust clinical trial in Canada, the United States, or maybe even in China or India. Like it's just a well-controlled, good study. It becomes much more difficult for regulators to say, this is completely bogus, don't take it, right? It becomes much more difficult to regulate stem cell tourism when there may be data that is signaling towards efficacy. So I think that's one of the reasons we need to get this right quickly, right? Because as stem cells move towards the clinic, it'll become much more difficult for people like me to say, all this treatment is bogus, don't get fooled, don't be tricked into spending your money. I know you're desperate, but don't go. It'll become much more difficult for me to make those kind of definitive statements if, in fact, we're moving towards the clinic in these more legit clinical trials.
Now, you said getting it right. What does getting it right mean in this context? What would you like to see happen?
If I had a short answer, I wish I had a definitive response. I think that dealing with stem cell tourism, and I actually think we could. This is something that is relevant not just to stem cells, but to a lot of these other cutting edge areas like genetics, for example. But I think it's going to take international coordinated action, and it's going to require not just, say, entities like the FDA and Health Canada, which can only really do stuff within their own jurisdiction. It is going to take the creation of strong international norms from science entities like the International Society for Stem Cell Research, the ISSCR. I think it's going to take strong action by jurisdictions in the context of truth in advertising. That's something we're looking at right now. What kinds of regulations exist that can sort of push these companies to be more truthful in their advertising. I also think that we need to turn to entities like the colleges of physicians and surgeons around the world, because there's some evidence that patients talk to their family doctors first, right? So if we can educate family doctors to respond to those patient questions in a honest and informed manner, that might go a long way to reducing the demand, right? Because people trust their family physicians, and if they can get good independent advice on what kind of stem cell treatments are efficacious, that might be useful. So I think bottom line is we need to use a whole bunch of different regulatory tools, a whole bunch of different kind of education tools in order to try to diminish this phenomenon, which is harmful not just to the patients, right? It's also, I think, harmful to science and harmful to society more broadly.
It sounds like we will absolutely be hearing from you on this topic again.
Well, thank you very much for the opportunity to talk about it. I think it's important stuff.
No, absolutely, Tim, and thanks very much for being here.
Oh, my pleasure.
You can find a link to Tim Caulfield and his book, The Cure for Everything, Untangling the Twisted Messages About Health, Fitness, and Happiness on our website at scienceforthepeople.ca. We'll be back with science writer David Dobbs to learn more about 23andMe and regulation in the personal genomics industry. Stay tuned.
On the next episode of Science for the People, we're looking at population and politics and what we can do to make human life on Earth more sustainable. We'll speak to journalist and author Alan Weissman about his book, Countdown, Our Last Best Hope for a Future on Earth. And we're joined by Dr. Chris Tyler, director of the UK's Parliamentary Office of Science and Technology, to talk about the top 20 things scientists need to know about policymaking. That's next week on Science for the People, on your local radio station, or online at scienceforthepeople.ca.
Welcome back to Science for the People. I'm Desiree Schell, and my next guest today is David Dobbs, writer at Neuron Culture and author of Reef Madness and My Mother's Lover. Great to have you back, sir.
Good to be here.
Now, you have been covering the continuing saga of the FDA versus personal genomic company 23andMe. So I definitely want to talk about that. But before we dig into it, let's start out by defining some terms. What is direct-to-consumer genetic testing?
Direct-to-consumer, also just for shorthand called DTC, this has developed in the past really 5 to 8 years, taking advantage of the plunging costs of getting some of your genes read, genotyped as it's known. You can contract with a company, and they will send you a little vial. You spit in it, you send it back to them, and they can tell you things about your genome. They can tell you select genes, the status of them, what alleles you have, that is, which variant of a gene that has more than one variant, or if you have genes with certain mutations. And they can analyze them for various things, ranging from a lot of information about your ancestry, like back through deep time, what part of the world your ancestors came from, to other things like how you compare to the average population for things like risk of heart attack or cancer of various sorts, that kind of thing.
So you send in your spit, and they send you a report, and along with the report, you have access to a genetics counselor?
You may or may not. This is why it's called direct to consumer. This is what's new. When I was back in high school many years ago, I worked briefly in a genetic counseling lab in Houston. It was there mainly to filter prospective parents to look at their chromosomes to see if they were at risk of having a child with Down syndrome. And literally, we cut up photographs of their chromosomes and based the analysis on that. But that is early in genetic counseling through the medical professions, which has been the standard for decades. What's new about direct-to-consumer is that the information comes straight to you, and it's not necessarily filtered through a genetic counselor. Some companies have been offering genetic counseling, and they have managed to stay out of trouble, but those aren't truly direct-to-consumer companies in the sort of pure sense of it. 23andMe stood out because it was a very high-profile seller of direct-to-consumer genetic testing, and it would tell you not only about your ancestry, but your risk factors in over 200 health conditions that had genetic components to risk.
So the industry has really only been around 5 years, so how has it been regulated, let's say up until a little while ago?
Well, not much, really. The FDA, as soon as this industry started in '07 was when 23andMe started taking vials of spit to tell you this stuff. And it wasn't regulated for a while. And a lot of people in the genomics industry wondered when and if the FDA would step in and assert a role. Now, there's a lot of some strong feelings among many in the genomics world that cheap genome testing makes possible a wonderful thing. A person can find out about this most basic thing about them. What is in my DNA? It is my DNA. Why shouldn't I know what's in it? That's the logic of direct-to-consumer testing. And the hope among many in the industry and many people in genomic researching is that this would remain largely unregulated outside of issues of like fraud, so that if I wanted to know what was in my genome and I had the money to pay for it, I could find out, and no one was going to tell me it had to be filtered through, a prescription, or that my doctor had to handle the information. So there was tension about that from the beginning. And in 2011, the FDA made some noises saying that they were considering regulating these tests as medical devices, which the FDA has purview over. And that worried a lot of people in the genomics industry and the direct-to-consumer testing industry. And it was in November, on the 25th, when the FDA finally dropped the other shoe and told 23andMe that they had to stop marketing tests that gave health risk information. So this was the first firm, hard, kind of traditional step by the FDA to control this information closely. They had been warning them and trying to work something out with 23andMe for months, actually for more like 18 months, and they weren't able to work it out. And I think a lot of people were hoping that they would work it out and that 23andMe would be able to go along doing business more or less as it was.
One of the interesting things about this story is that, for the most part, it seems like the FDA was fairly accommodating with 23andMe.
It does seem that way. It's a little bit hard to say. These talks have been going on for almost a couple of years between the FDA and 23andMe. We know very, very little about them. We knew almost nothing about them until the FDA sent this very sternly worded letter on November 25th, referring to a whole string of negotiations in which they were trying to agree, apparently, from the FDA letter, on what 23andMe needed to do to verify the accuracy of its tests and its health risk information that it was giving consumers. So what they wanted to do, it seemed, was to ask 23andMe to sort of show their homework behind telling me, for instance, that according to my genetic test, my risk of getting Alzheimer's before I'm 80 is double the usual risk rate, raising it to about 13%. And it did sound from that letter as if the FDA had been very patient. Now, we're getting mainly one side, but right. What we don't know and still remains kind of foggy is what level of sort of proof and verification of these tests and the health risk information the FDA was asking for. Because at one level, they could simply ask for, show us the literature that tells us that David's Alzheimer's risk is 13% instead of 7%. Right. That's one level. Another level would be document the entire chain of every single vial of spit that goes through your system and document every single finding that you are attaching any significance, finding in the medical literature that you're attaching significance to. So it could get very detailed, and if they were asking 23andMe to have a thorough documentation or independent verification of each risk factor and chain of custody and documentation of every step of the genetic testing itself, that would be an impossible, not an impossible, but an impractical thing to do. It would raise the cost of doing it so high that it would destroy the market. And we still don't know exactly what they were asking. But whatever it was, 23andMe finally realized they couldn't do it, and they agreed in December to no longer offer the health risk information. And this is a huge thing because 23andMe was a fast-growing company, and it was the standard bearer for this new idea that I can get my genetic information and a readout of what the literature says about its implications for my health because I have $99 that I'm willing to give to 23andMe. Now that's not there. I can get the readout of the hard-coded readout of what's in my genome, but if I want to figure out what it means, I have a lot of homework I have to do.
So now, after that letter was sent, it doesn't seem like 23andMe complied immediately.
No, this was it was sort of it was a very stern letter, which said cease immediately marketing these tests for health risk information. You have 10 days to stop, or we will take other measures. And this is the FDA. They can hurt you pretty bad. And for 10 days, and then a few days more, if I recall, there was almost no answer from 23andMe. And they're right on their website, they were still marketing this stuff. Now, you can argue about what the word marketing means, but they just didn't seem to be responding, and everyone was wondering what was going on. So that's when a lot of speculation about 23andMe's position started. Maybe people thought they're doing this to provoke a heavy-handed action that would sort of move the negotiations out of the usual bureaucratic arena and into a public or a legal arena. It turns out that probably wasn't the case. They had not responded to anything from the FDA for 6 months at the time the FDA sent the letter, which helps explain why the letter was rather testy, I think. And as best as anyone can put it together, it looks as if 23andMe largely simply dropped the ball. Their lawyer who led the effort on this left last summer, and it appears that the issue simply did not get as much attention in-house at 23andMe as it should. Now, it's possible that as an organization, 23andMe simply didn't didn't take this seriously enough, which is a little hard to fathom, but there is a huge cultural gap here between, the Washington, D.C. traditional health regulatory world and the world of Silicon Valley, which is it's used to doing largely as it pleases. There's a lot of libertarian values there. It's an exciting, fluid place where people move quickly and are usually fairly unhindered by this kind of regulatory atmosphere. And it's possible the company simply didn't take that seriously enough and was taken by surprise. It does seem they were taken by surprise.
I really think that we could make a great mini-series out of this.
This is the thing. As a journalist,
science fights are the best fights.
Yeah, science fights can be very good. I'm working on another book right now, but I can't help but think that there are some juicy stories here somewhere about the negotiations, how they broke down, the clash of cultures. There's some stories to be told here, almost certainly. And in a way, that's just interesting. But it's interesting for a reason that has wider implications. And that is that there's so much we still don't know about what broke down here. Well, we don't know what the FDA was asking. Was the FDA asking something completely unreasonable, and that they're trying to force the genetic testing industry into a very narrow corral that they have to operate in? Which, if that's the case, that may cripple, at least for a time, this sort of direct-to-consumer testing. I think it will emerge some other way. This is kind of like trying to corral digital music.
Oh, I remember that.
Yes, right. We remember that. That's only about 10 years ago.
Right.
And the record companies were determined, no, we're going to keep it in albums. And it didn't work. And a lot of people argue very convincingly, this won't work either. Because I can still get my spit and get my DNA readings back. Now all I got to do is find someone else to interpret them for me. And if they're not using a device, is that interpretation? Is that a medical device, or can they do it efficiently enough so that it becomes affordable? So this won't destroy the industry. It will destroy the form that it was taking, where one place could take your spit and then give you a readout based just on the literature on your health risk. A lot of people, and I'm among them, think that's too bad, but a lot of people, and I'm among them, also think that there will be a workaround for this, and in somewhere between 2 and 5 years, we'll be able to get the same kind of thing through maybe some process slightly more kludgy.
You're tuned into Science for the People, and I'm talking to David Dobbs, writer at Neuron Culture, about some recent developments in direct-to-consumer genetic testing. So let's talk about the arguments here specifically. What are the arguments for direct-to-consumer genetic testing being considered a medical intervention? Because this is really central to the 23andMe case.
It's essential to the FDA's case. Their argument is we get to regulate this because this is a medical device. And of course, from a strictly legalistic sense, they can regulate something simply because you're spitting in this. It's not that it has to be truly invasive, like a syringe or something. They have different levels of regulation for different kinds of devices. I mean, in the FDA's view, a condom is a medical device. It's at their lowest level of regulation, but because it has medical implications. So from a strict legal sense, the FDA has a very good case. However, from a sort of conceptual sense, it gets kind of strange because the device is simply a container that holds your spit and then a bunch of machinery that analyzes it. And those are not inherently medical because genealogy places like Ancestry.com are using that same procedure to tell people about their ancestry, and they're not being regulated at all. And there's no talk of regulating them. What makes it the medical device here is the interpretation, the medical interpretation of the health risks that are latent in the genomic information.
Well, there are definitely those who take the position that receiving these reports might do someone more harm than good.
Right, and it's not a slam dunk on either side. This can be very alarming information. I was and still am a 23andMe customer, And I remember getting my results and being very excited. I'm looking up this and that and the other thing and learning that I have a little bit more risk of this thing and a little less of this. And I'm also getting information that's communicating to me, if I'm paying attention, it's reminding me that this is all probabilistic. It's not a straight line from a result to an outcome, but these are probabilities, and they're not all right. It's part of a big picture. For instance, I'm supposed to be shorter than usual according to 23andMe's analysis. I'm 6'3". I'm supposed to have lost all my hair. I still have it. So there's these things that tell you, take these with a grain of salt. However, when I got to the bit about Alzheimer's, there was an extra layer of clicking I needed to do to find out my Alzheimer's information. And I do remember when it revealed that my risk was doubled to 13, that it was awfully easy to get that information that was that powerful. That was because I had one copy of this Alzheimer's risk gene. If I had two copies of this risk gene, my risk of getting Alzheimer's would have been in the neighborhood of 80 to 85%, which that would have been quite something to process. So this is the kind of information that genetic counselors worry about people struggling with. And I think that's reasonable because information can be very powerful. Now, on the other hand, there's a lot of evidence that shows you can give people this kind of information, and even if it kind of sets them back a step, the way my Alzheimer's information did for me momentarily, they deal with it, and they usually deal with it in a healthy manner, and they don't tend to panic and do something wild. There was a commentary in Nature, the scientific journal Nature today, by a pair of people, Robert Green, who's a geneticist at Brigham and Young's and Harvard Medical School, and Nita Farahani, who is at the Duke Institute of Genomic Sciences. And they took the FDA to task here. They said this was an unreasonable thing, that a study they did and studies they mined have shown that people do not panic, that 42% of people who get this result make positive changes in their health behavior, and only 1% of all of them did so much even as alter prescription treatment without consulting a doctor. So they make a strong case that the FDA is over-worried about this nightmare scenario, that someone gets one of these results and does something radical that's harmful to them because of it, whether it be stop a medical treatment or find some off-market drugs that aren't good for them, that sort of thing. But this is the tug of war that's going to go on about this for a while now.
In your opinion, then, is what the FDA wants reasonable? And I guess not just your opinion, because there are bunches of people on both sides, and I know many of them.
Part of the mystery there is, what does the FDA want?
Right.
And this is the tragedy, that this thing was bungled by 23andMe, because no one really knows right now if they had been more responsive, if the FDA, which, as we mentioned before, it did seem to want to be reasonable about this. Might they have been a few reasonable hoops to jump through that they could have jumped through and made this thing work? We don't know. I think, though, that if the FDA does want manageable things like that, so that reasonable concerns about processing the highest risk, highest impact medical information that they're offering, or that they were offering, can be answered, I think everyone would agree that that's a good thing. If the FDA is trying to do this old school, where they want piles of documentation about every single individual genetic test that 23andMe is offering, we're rolling way back in the movement to something that I think most people do agree is healthy, to ready, affordable access to health-related genetic information.
Do most people think that?
You know, I have not seen a survey, frankly, so I may be talking off the top of my head, but there's a great argument for that, as long as it's presented reasonably. And it would be a tragedy if it were made, I think, very expensive. There was early talk and moves by some in the medical professions to choke this off so that you would have to get a doctor's prescription to get some of these tests. And a lot of places you you still need that for some kind of tests. If you want to get your serotonin transporter gene genotyped, it's very hard to get a lab to do it for you without a doctor's order. Now, that's a gene that, depending on which form you have, the literature shows that you may be at higher risk of depression in reaction to stress. It's hard to get that test without a doctor's permission now. So that's a very kind of occluded, kind of sclerotic way for someone to get information that's in their spit. And there's a sort of justice issue there. Right. Do you have the right to your own biological information? Since the technology can be made cheap and can be made readily available, should it be available? And there's plenty of room for argument in this. But I think there is a sort of a Venn diagram overlap between what, DTC advocates, most of them would argue for, and what people who, like genetic counselors, who want at least a little bit more filtering on some of the information to stay in place. That there's a way to meet both those ends that is still reasonably inexpensive.
There is a lot of quackery out there in the world, and I'm wondering why the FDA seems to be coming down harder on 23andMe than on, say, something like sketchy supplements or homeopathy or things of that sort, things that have never been proven to have any medicinal value. Whereas 23andMe, there's debates to be had, but this is not fraud or quackery. So why do you think there's a difference there in the way that the FDA is treating this?
That's a very good logical question. If there's all this stuff you can take, and some of it has been shown to be harmful if you take too much of it, and there are people who take too much of it because they're told it's great for you, why isn't that regulated? And the technical answer is it's not legislatively under the FDA's purview. At the same time, there are places that you can send off a spit test and they'll offer you advice on dating, what kind of people you should date. There are places that will do a brain scan and tell you what kind of people you can date. And an fMRI machine, that's a pretty big medical device. As it happens, they're giving romantic advice instead of medical advice, but this is the sort of quackery that comes to mind, and you think, well, there's no justice, this doesn't get regulated. And it gets back to kind of the legalistic definitions of what the FDA's purview is, and it just doesn't happen to fall under them.
Well, now you've been looking at this topic for a while now, so in your impression, what's the ideal outcome here?
I think the ideal outcome would be, this is very optimistic, but that we'd find out in 3 months that the FDA and 23andMe just had some really bad misunderstandings, plus maybe 23andMe dropped the ball for a little while, and that the FDA was asking them for reasonable things that the company, given some focus and effort and money, could meet reasonable demands. Maybe it's an extra layer of filtering, as I suggested before, for high impact information so that you can get all your health information for $99. But if you want your information about, Alzheimer's and a couple of other things, you pay extra and or simply agree that to get to those, you will get them through a genetic counselor. So I think that's a sort of good outcome that could still occur. I don't think it's unreasonable to think something like that could occur. It's a mystery whether that's in the works.
Let's cross our fingers, shall we?
It'll take at least that, I have a feeling. I do think that the most likely scenario is that over the next 2 to 3 years, as the FDA makes more clear what it wants and other companies think about how to meet this demand, the desire people have to know their health risk information based on their genetic data and understand the limitations of that information, that someone else will figure out how to meet that demand without getting caught in the bind that 23andMe did, where they were collecting the spit and interpreting the genomic information. They were doing a whole full service. If you cut those up, it might be easier to get this done.
David, I love your coverage and always wonderful to have you here.
A pleasure, as always.
We've linked to David Dobbs and neuron culture on our website at scienceforthepeople.ca. And of course, there are also a ton of links on our website to everywhere that we exist on social media, so click away. Thanks for listening, and we'll see you next week on Science for the People.